Hello, and welcome back to another video. Today, I'm going to show you the difference between the box, RC, ARC, and Mutex smart pointers. As always, if you find this video helpful, please remember to leave a like and subscribe. Let's begin with a box. A box takes a piece of data and places it on the heap. This is especially useful in situations where you don't know the amount of memory that you need at the time that you are writing and compiling your code. So a helpful example of this is a linked list. A linked list can have a potentially infinite size. For anyone that isn't aware, a linked list is a series of nodes that are linked with one another via memory reference. So if I am writing a linked list node in, say, JavaScript, it generally looks something like this, where I simply define the object with a value and a next, and just say, hey, this is the next reference. But in Rust, since we don't know how long this list is at the time of compiling, it throws this error saying recursive type has infinite size. And so in order to resolve this, we need to give it a defined size. So a box has a max size. It varies based upon the data that it is given, but by defining a size for it, we can let Rust continue on with its memory safety. So a thing to note is that a box is a reference, and when you try to access it, there is no guarantee that the value is still there. So what you actually need to do is wrap this in an option, because it can be a none value, and that's a box. Next, let's define RC. RC stands for reference counted, but I personally find it more helpful to think of it as reference copier. So what an RC does is it creates a new reference to an existing piece of data. So you can have two references that can be owned separately that are both pointing at the same structure, for instance. So let's walk through an example. We are going to import RC from standard RC, and we are first going to show why this is important. So we're going to use an owner and his tools. So one owner can have many tools. A tool can have one owner. So for the owner, we will have a name, and he can have a list of tools. For the tool struct, can have owner, and it'll be of type owner. Now here, if let's say we'll call this person Brad, and we will create a new owner, name Brad to string, and tools will start out as an empty vector. All right, That works just fine. We'll say he has a pair of pliers. Tool owner is Brad. Okay. But Brad has now been moved to pliers. So if we try to define his wrench, you'll see that that is the error that we get here. Use of moved value Brad. So the way that we get around this is that we create a new reference to Brad instead of moving Brad directly into the pliers or wrench struct. So in order to do that, we define owner as being of type RC owner. And in order to create a new reference, we can do one of two things, or two different things. We can either use RC clone and use and pass in the Brad reference, or we can call it directly on Brad, brad.clone. Now, in order to actually define that Brad is a RC, we need to wrap it in RC from. Perfect. Now we don't have ownership issues, and we're good to go. Now, the next part of RC that I want to show you is the weak version of RC. So RC is the strong version, and it has a weak version. Weak guarantees the reference, but it does not guarantee the value. So you may still have the reference to, let's say, pliers or Brad, but there's no guarantee that the value is still there. And where this weak comes in handy is in the same situation. So we have a owner that has multiple tools, and the tool has one single owner. So there is one Brad, the tools reference the one Brad. But if we want this list of tools to be owned by Brad, we want to actually create a vector of weak tools. And we don't want to use RC here because RC, in this case, can lead to a memory leak. And we're going to do one more thing here. We are actually going to define the tools vector as a ref cell so that we can borrow a mutable version of it. And then down here, and we have a ref cell. Now, to show you how to update it, we're going to call Brad tools borrow a mutable version of Brad tools, and we are going to push pliers. So right now this will error because it is not a weak version of pliers. In order to create a weak version of a reference, which we actually need to wrap this in, wrap both these tools in RC so that they are RCs. And we need to downgrade them from a strong reference to a weak reference. And pass in the reference to pliers. And we will do the same thing for wrench. Now, reading the pliers and wrench is straightforward. So if we wanted to print out pliers owner, we would simply write pliers.owner.name. Super straightforward, easy. Now when we get to Brad, if we want to print a tool out, we're going to have to upgrade the weak references to RCs in order to have actual access to the value. So Brad's pliers owner, and we're going to reference brad.tools, borrow a reference to the tools vector, access the first one, and upgrade. So this returns an option that is either none or the value of the weak reference. So in order to get the value, we're going to call unwrap. In this case, you can use a match, but since I know that it's populated, I'm going to use unwrap. And finally, we can reference owner and name. And now, if we come into our console and we run the program, we can see that it prints out pliers owner Brad and Brad's pliers owner Brad. Perfect. And that's RC. Now let's talk about ARC. So an ARC is essentially the same thing as an RC, except it is used primarily when there's multi-threading involved. Where an RC guarantees a reference in a single thread, an ARC guarantees a reference when used across multiple threads. So to start, we are going to import ARC and weak from the standard sync library. We are also going to use standard thread to multi-thread. We are going to once again define an owner with a name of string and a list of tools. We'll start out with weak tool. Same for the tool struct. It once again has an owner, but this time it is an arc owner. And if we come down into our main function, I'm going to create two print lines for readability sake. Arc begin and print line arc end. I'm going to once again define Brad, arc from instead of RC from, owner, name Brad, and a list of tools that is a vector. We're going to loop 10 times and create a new thread for each loop iteration. And we will define let child pliers thread spawn as an arc, a movable closure, tool owner is arc clone, and pass it a reference to Brad. And then likewise, arc from tool owner is brad.clone. So same setup as the RC. Now you'll see here that we have an error. Move is saying move occurs because Brad has type owner and it does not implement the copy trait. So Brad moves with each iteration of this for loop. In order to resolve that, we need to create a new reference to Brad in each iteration. So we'll define Brad again, clone Brad. And we no longer have that move error. Like in the last one, I want to see the player's owner. So print line player's owner and grab the players.owner.name. And I also want to print out the current thread number when it ends for clarity. Now, in order to actually get this thread to run, we need to call child.join. So this will actually make it run. Now, if we come into the console here and we run this program, you can see that we have ARC begin and then 10 iterations of player's owner Brad and thread number end. And finally, ARC ends. And that more or less takes care of ARC. ARC has more methods. I invite you to explore those on your own, but this is the primary use case for ARC. Lastly, let's get into Mutex. So we're going to be using the same example. A Mutex provides memory safety when accessing and mutating data across threads. So it is located in the same sync library, Mutex, and we are going to define this tools property as a mutex that contains a vector of weak tool references. So down here, we need to define a new mutex for the tools, and we are going to now access the mutex and update it. So we've created our two tools, players and wrench, and we want to push those to Brad's tools vector. So first we need to get a mutable guard. So this is the mutex guard that is generated when accessing a mutex. Brad.tools.lock. So we are requesting access to the location in memory and locking it until we are done using it. So by locking it, this prevents other pieces of code from accessing that same piece of memory. This lock becomes unlocked once it goes out of scope. So if I were to write down here, request another lock, it would actually hang my program until I manually kill it. So once we lock our access to the tools memory, we need to unwrap it. So again, you can use a match This is a result. So it can either be an error or a value. Next, we are going to use the vector and push our ARC and once again downgrade it to make it a weak reference and pass in pliers. And then same thing for the wrench. Now in this case, if I want to see the first item in Brad's toolkit, I need to utilize the guard, grab the first one, upgrade it back to an ARC, and access the owner.name. And actually utilize. And once again, this is a option, so we need to unwrap it and we should be good to go. So let's give this a run. And you can see that we get an error. So this is because the pliers and wrench don't exist once this thread goes out of scope. So the pliers only exists for this current scope. So in order to resolve that issue, up here where we have Brad and we're cloning it, just like how we have Brad initially defined up here, we have to define it for each iteration. We have to do a similar thing with pliers and wrench. So we are going to actually do this. Initially define pliers and wrench up there. And we are going to clone the reference to pliers and wrench down here. And wrench. Sorry, these two are actually supposed to be right here before the thread is defined. So now if we run this, you can see that it works out correctly. So we have 10 iterations of Brad's pliers being written out and the pliers owner being written out. And that takes care of mutexes. Thank you for watching and have an excellent rest of your day.